Hi everyone, I'm a staff of KDD Cloud Multimodal Retrieval, Junyang Lin. I'm from Laboratory of Intelligent Computing, Alibaba Group. Thanks for your participation, and this competition is a great success. Now please allow me to review this competition and summarize the progress that you have done. Okay, back to our motivation. Actually, we hope that we can hold this competition to promote the development of multimodal representation learning and its application to detailed tasks. Now you see, retail e-commerce has been developing very rapidly, and there has been a rapid growth of information of modalities, such as articles, videos, and lives, except for items of product in traditional e-commerce platform. Now, most e-commerce platforms and retail companies achieve their targets by using their search and recommender systems to boost their sales. So if we want to improve the effects of search and recommender systems to provide better service to the users, we actually need to develop a model framework to facilitate multimodal representation learning and multimodal semantic understanding so that we can improve the effect of retrieval of images and videos and even the traditional items, so we can provide better services to the users. Moreover, there is a common problem in search and recommender system called the Matthew effect, which means that a few items get most of the page views. So this problem comes from the search and recommender systems, which depends on user behaviors. So if the items have few user behaviors, they have less chance to be exposed. So to solve this problem, maybe multimodal representation learning is a way to tackle, to alleviate the Matthew effect. So based on these motivations, we hold this competition, and also we ourselves have some progress in this field. Well, let me introduce our progress in multimodal representation learning. In fact, we focus on multimodal pre-training. Actually, pre-training has been proved very successful in text, in natural language processing, but actually it's also successful in multimodal representation learning. So we study the advantages and drawbacks of the current multimodal pre-training models, and we found that there are mainly a single stream model and two stream model. So we combine their advantages to build our interpret, so we can use the advantage of single stream interaction and the advantage of the two stream independence, so that we can build a more robust model in multimodal representation learning. Furthermore, in order to improve the effects of the model, we design more difficult tasks for the model to learn, more difficult pre-training tasks. For example, in traditional pre-training, masked language modeling is a common task, but we turn it into masked group modeling or masked band modeling. For the images, we have masked region modeling, so the model should predict several words in a time and predict several objects in a time. Also, for the image text pair, we build more difficult negative samples so that the model can learn a better relationship between the positive one and negative ones. Our interpret actually improved performance on the over the baselines in several tasks, such as caption-based image retrieval and visual common sense reasoning. Well, back to our competition, let me firstly introduce the data description. Okay, the dataset that we provide is actually from Taobao, a Chinese e-commerce platform. We provide the search queries and the product image features. So we organized it into a query-based multimodal retrieval task. The participants need to use a query to search the most relevant images of products. Actually, it's a retrieval task. It can be regarded as a query-based image retrieval task. Our training set consists of 3 million of query and ground truth product image features. So these pairs can be taken as the positive examples. And you need to build your own negative examples to train your retrieval model. So how to extract the negative samples is an important part of this competition. For each product image, actually we release the features that we extract by our trained faster RCNN. So we provide the object features and their corresponding locations and classification labels, so that the participants can use these features and the locations and use it into the multimodal trained models. For the validation and testing, we provide a valid set of around 500 queries, and the testing set has A part and B part, and each of which consists of 1,000 queries. For each query, we actually provide a candidate pool of around 30 products of images. So you need to search the most relevant products from these 30 products. The ground truth products for the testing set A and B were not released during the competition. As to the evaluation, we compute the NDCG@5 on the testing set for each participating model. NDCG@5 evaluates the correspondence between the retrieved product and the ground truth. To be more specific, the top ranked product is ground truth, will have greater impact to the score than the latter ones in the prediction. The final ranks of each participating team are determined by the NDCG@5 on the testing set B. While we can find that many teams have achieved a very satisfactory performance, and over 22 teams have beaten our baseline model, which is based on a multimodal trained model, and achieved very outstanding performance. Specifically, the top 10 teams that have won the award outperformed the baseline by over 30%, 13%. As to the trends of this competition, we can find that pre-trained models have been more popular than ever. Pre-trained models have been proved very successful in natural language processing and computer vision, but actually it is also very successful in multimodal representation learning. So in this competition, we can find that pre-trained models are very contributive to the final performance. But for the conventional method such as ensemble is still a very important method for satisfactory performance. If you use ensemble and pre-trained models together, you can have a very large improvement on your model. But for the data processing, it is still important because our provided data is very complex. So you need to clearly pre-process and post-process the data so you can achieve better performance. And as we build a task of image retrieval, so you need to use better negative sampling to train your model for higher evaluation score. Well, in all, the participating teams have achieved very nice performance, and we can find that their methods are also contributive to the development of multimodal representation learning and its application. So thank you for your participation, and it's a wonderful success. and I hope you enjoy this competition. Thank you very much.